Hey everybody, this is Mr. Ainsworth. We're going to get into a big Unit 2 review here covering Chapter 5 in your textbook here, Sections 1 through 5 on linear functions. So this covers a lot of concepts, and so be smart about this. Take out all your notes, all right? Get a pencil, red pen, straight edge, all that good stuff, and use your notes because guess what? We took them for a reason. So get them organized, use your notes. And remember, this is a video, right? So you can pause and play and use it at your own pace. All right, use it effectively. All right, let's start off with the given linear relation here, which is just a set of ordered pairs. We want to find the linear function a couple different ways. First way, using slope-intercept form, and then use point-slope form. All right, to use either one, you have to find the slope, and to do that, we got to find the change in x and the change in y, or what's called the rate of change. All right, now starting with the x values here, with the rate of change from 2 to 4 is 2 because it's increasing. From 4 to 6, it's an increase of 2, and from 6 to 8, all right, it's an increase of 2. So the rate of change on x is constantly 2. Here we'll call that delta x. Delta means change. I talked about that in my initial lessons here. All right, so in mathematics we say delta x, or rate of, or the change in x here. Now the change in y, well, it's increasing as well, right? From 9 to 19 is an increase of 10. From 10 to 29 is an increase of 10. And from 29 to 39 is an increase of 10. So delta y is 10, or the change in y is 10. So when you find your slope here, which we use m for monter, all right, this comes from French here. M from the French word monter, meaning to climb. There we go, to climb here. You need to find, okay, delta y, and which we did, and divided by delta x, okay, and divided by delta x. Always change in y divided by change in x to get the rate of change or the slope. So for us on this case here, this is equal to 10 divided by 2, okay, and that's usually 5, especially today. So we know the slope is 5. There's your slope. So because of that, I take my slope, all right, and I substitute it into my function. So I know that it's going to be y equals 5x plus something, all right? That b, let's put a question mark over b here. I don't know the y-intercept because it's not in the table. Okay, it's not here. I took it out. Okay, and for those people that actually look closely here, if you want to find the y-intercept to find b, there's a couple of different ways you can do it. You can use your rate of change and go backwards and find the y-intercept, or you can use a point, all right, like I don't know, pick this point maybe, 2 comma 9, and you can substitute it in and find b, because x is 2 and y is 9, right? So if you use your point, it looks like this: y equals, or say 9 equals, excuse me, 9 equals 5 times what the x value is, and x is 2 in this case, all right, plus something, all right? That b is some value, it could be positive or negative depending on the function. Okay, and so what you do is you work it out. All right, so 9, that equals 10 plus something. Okay, when I say b, that means some value. If you want to solve for it, you can. If you want to think about it, you can too. 9 plus negative 1, excuse me, 10 plus negative 1 is 9. All right, so I know b is negative because 10 minus 1 is actually 9, so b has got to be negative 1. Or you can subtract 10 and go 9 minus 10 is negative 1. Either value, or either way, you get negative 1. All right, so that tells me that my function looks like y equals 5x minus 1. That's using point-slope form. Y equals 5x minus 1, or plus negative 1 if you want to write it like that. All right, if you wrote it like this is fine too. All right, b is negative 1, either way. Most people write it like this. All right, plus negative 1 is the same thing as minus 1. So if you use a rate of change and you work backwards, that means you subtract 2, because you going forwards you add 2, going backwards you subtract 2, and that make that 0. Going forwards you would add 10, so going backwards you subtract 10. So going this way you go minus 10 or negative 10. Excuse me, 9 minus 10. Let me rephrase that. So 9 minus 10, that'll give you negative 1. And notice that the y-intercept is negative 1. That's your y-intercept in the table. 0 comma anything is your y-intercept. So if you want to use your rate of change going backwards, you may. All right, now that's using point-slope form. using the first technique here. Now there's something called, excuse me, that's slope-intercept form. Come on, Ainsworth. All right, there's something, I was looking ahead right here. So there's another technique called point-slope form, and it's what we practiced in section 5.4. Slope-intercept form, that was sections 2 and 3. All right, so sections 5-3 and 5-2 in your textbook. Okay, and slope, that's section 5.1. So if you want to look at the sections in your math book, these are the sections, just to let you know. All right, so let's use point slope form here. Let's pick a different point. Okay, let's get a little creative here. Let's use this point here. Let's use 4, 19, just because we can. It doesn't matter which point you pick, where x1 is 4 and y1 is 19. All right, so we have y minus the y coordinate, which is 19. It's right here. All right, equals the slope. We already found the slope of 5, right? Times x minus the x coordinate of 4. So if you work this out, you have y minus 19 is equal to 5x. All right, you got to distribute twice here, so minus 20. And then if you isolate your y value, you get, after you add 19 here, you get y is equal to 5x minus 1, because negative 20 plus 19 is negative 1. All right, and notice they are the same. And that tells me that we did it right. So I'm a happy guy, so put a happy face right there. All right, these must be the same. So this function is the same as this function here. All right, you back each other up. So no matter what method you use, all right, you better get the same linear function. Again, we're trying to find a linear function here that describes this set of ordered pairs. So just in one example here, I reviewed rate of change, I reviewed slope, I reviewed how to use slope-intercept form, and I reviewed how to use point-slope form, all in one problem. So this is a great review. Get you ready for your test later on. Now the second example is the same idea, right, but different numbers. So let's get used to it. Let's find the rate of change of x here. All right, from 2 to 5 is an increase of 3. From 5 to 8 is an increase of 3. From 8 to 11 is an increase of 3. So the delta x here, the change in x is 3. Change in y, well, it's decreasing from negative 3 to negative 9 on the number line. You're going left, okay, and you're getting more negative, which means you're decreasing, which means the change in y has to be negative. All right. So what would you subtract from negative 3 to get to negative 9? And the answer is minus 6. Negative 3 minus 6 is negative 9. Minus 6 more gives you negative 15. Minus 6 more gives you negative 21. And that is called the change in y, or delta y. After that, you find your slope. The slope, we denote by m for monter in French. Remember that? Monter means to climb, as in a hill which has slope, and that's why the French use m there. All right, so let's go, let's take negative 6 divided by 3. You always take delta y and divide it by delta x. All right, negative 6 divided by 3 is negative 3. So the slope here is, not negative 3. It's a very common mistake, negative 2. Come on, Ainsworth, negative 2. So once you have the slope of negative 2, you substitute it in. All right, so I start with y equals negative 2x plus b. All right, I know the slope, so substitute it in. The only thing I need to do is find the y-intercept. And as I said earlier here, you can use the table for that. You can go backwards if you want, if you know how to do that, although subtracting 3 would put you at negative 1, not 0. So using the table might be kind of hard, but using this point right here is not hard at all. So I'm going to substitute negative 3 in for y, because it's a y value. Look on the table, it's a y value, equals negative 2 times the x value, which is 2, plus something. Let's just solve for b. I mean, if you don't know what it is and you don't know how to do it in the table, then why don't you just solve for it? Pick a point like I did. You can pick any point you want and substitute it in and figure it out. So negative 3 equals negative 4 plus something. And if you don't know what you add to negative 4 to get to negative 3, if you can't do it common sense wise, then we'll simply add 4. And 4 minus 3 is 1, so b is 1. And if that's the case, look right here. All right, y equals negative 2x plus 1. So you write out the function and you're good to go. All right, now that is using the point-slope form. Excuse me, slope-intercept form. All right, because I used a slope and I used a point, and then I found the y-intercept. I'm using the slope-intercept form, y equals mx plus b. If you use a point and a slope directly, all right, and you don't find the y-intercept, well, then it's called point-sum form. And just for funsies here, I'm going to pick another point. I'm going to pick 5, comma, -9 because it doesn't matter which point you pick. 5 is x1 and -9 is y1 here. And you substitute them in. So you get y minus the -9. Be smart about that. You got to subtract the y value. So subtract a -9. Keep track of your negatives. All right. The slope already know is -2. So -2 times x minus the x coordinate of 5. All right. And then you solve for y. Or you can say isolate y. However you want to say that. Solve, isolate, same thing. Now, you notice right here, there's a double negative, right? Y minus a -9 is y, ooh, check this out, y plus 9. So you add the opposite right there, y plus 9, and that equals -2x, because you distribute, right? Keep track of your negatives here. Negative times a negative is a positive, so plus 10. Then after you subtract 9, you'll see what I'm talking about here. You get y equals -2x plus 1, because 10 minus 9 is 1. And guess what? These are the same, right? And that is, well, that's a good thing, right? Because no matter what method you pick, you better get the same function. I mean, it wouldn't make any sense if you use two different methods and not get the same result, okay? In mathematics, things have to make sense. So no matter what method you pick, or no matter what method you use, you should get the same result, which is y equals -2x plus 1. They should be identical. And also notice that in the first one here, the first method, slope-intercept form method, I used the first point 2, comma, -3. And I substituted x2 into x and -3 in for y. You'll see the substitution right there. And then the second one, the second method, point-sum form, I used a different point, and yet I got the same result. And that proves to you guys that no matter what point you pick in the table here, you're going to get the same result, as long as you do your arithmetic right. All right. Okay, so now this right here is all about standard form, and in this section you can look in your notes. It's section 5.5 because you guys are supposed to be using your notes effectively, and guess what? It's section 5.5, so take them out. And when you use the method of zeros or to find the y-intercepts here, you put your zeros in your table. All right. First you substitute 0 in for x, and so let's do that. Let me rewrite the equation here. So 2x minus 4y equals 8. You put 0 in first, and then solve for the other variable, which is y. Now, what's cool about this method is that anything times 0 is 0, so you get just -4y equals 8, and that means that y has to be -2, because -4 times -2 is 8, so y is -2. There's your y-intercept. So -2 comes, excuse me, come on, Ainsworth, 0, -2, 0, -2. The next one, you put in y, 0 for y, so you get 2x minus 4 times 0 equals 8. Notice that wipes out, cancels out, because anything times 0 is 0. And you get something really simple. I mean, look at this. 2 times 4 is 8, so x is 4. So you get 4, 0 in this case. And that's called your x-intercept. So this one is your x-intercept. This one is your y-intercept, and it should be obvious because this is a y value, so it's y-intercept. 4 is an x value, so it's an x-intercept. Okay, just try to make sense of it. And you plot it. At 0, -2, you're here. 4, 0, you're here. All right, so there's your x-intercept. Here's your y-intercept. Oops, y-intercept, there you go. Because it's on the y-axis there. Take your straight edge out and draw your line. There you go. All right, now, the other way to do is isolate y. So let's do that. So 2x minus 4y equals 8. In my original lesson here in section 5.5, I showed you two different ways to graph the same thing, because everything should back each other up and make sense. I mean, if you add the opposite here, all right, you get -4y equals -2x plus 8. All right, make sure you bring down the negative sign there on the 4. All right, divide everything by -4, and I mean everything, guys. All right, everything. Divide everything by -4, and you get y is equal to, ooh, look at that, 2/4, 1/2, x, 8 divided by -4 is -2. There's your slope. There's your y-intercept. It's in slope-intercept form. So slope is 1/2, b is -2, and guess what? When b is -2, just look. All right. All right, and the slope of 1/2, check this out. From here, you go up 1, right 2, up 1, right 2, 1/2. And so it's that staircase, that famous staircase effect right there in the slope. You rise and you run, okay? This is your rise, and this is your run. So that means that you go up 1, right 2, okay, from the y-intercept. All right, you always start at the y-intercept. All right, always start at the y-intercept. So this method here backs up with what we did over here on the left using intercepts. So the first one was the intercept method. Okay, look at your notes. It's the very first thing I did in the lesson here. And the other one was slope-intercept form method using the slope and the y-intercept. Okay, like I said, I am reviewing everything. I just reviewed section 5 a little bit, not the entire thing, but a lot. In the previous problem, I went over section 1, 2, 3, and 4. So I just covered almost the entire majority of the chapter in 2 problems. Okay, now let's go to section 5.3. All right, graphing in slope-intercept form, which is y equals m times x plus b, right? The slope here is 1/2. The y-intercept is -3. In this section here, when I first introduced this, though, I graphed by plotting points. So in this section, we're going to do the same thing. We're going to graph by plotting multiple points, and then we'll back it up with the slope and the y-intercept. Okay. So you can even get out your notes on that. Just find the one that says graphing a linear function by plotting points and take a look at it. Now I give you a big tip right here. So when you plot a bunch of points, you need at least 2 points. So let's write that down. You need at least 2 points. Now I always suggest 3 or more because the third one checks your first 2, because they should all line up, and if they don't, you made a mistake. So because the denominator here is 2, when I say pick an appropriate domain, okay, I'm talking about looking at the denominator if there's fractions and using multiples of the denominator. So for this one right here, I can say, okay, I can start off at -4, then -2, and then 0, and then 2, and then 4. I can input these values and get y values, and then I can plot, okay? All you have to do is do arithmetic. So it's 1/2 times x. This is times x right here, so times -4. All right, -3. Now, a half of -4 is -2. -2 minus 3 is -5. There's your y value. So left 4, down 5. Left 4, down 5 is right here. There's your first point on the graph. Next one is 1/2 times -2 minus 3. Well, a half of -2 is -1. Minus 3 gives you -4. So that's left 2, down 4, which is right here. All right, next one is 1/2 of 0 minus 3, which is just -3 because anything times 0 is 0. Okay, and so 0, -3, where is that? Well, it's just down 3. It's right here. All right, and then you input 2, so 1/2 times 2 minus 3. Well, a half of 2 is 1. 1 minus 3 is -2. So it's 2 comma -2 is right here. And notice they're all lining up. And then you take a half of 4 and then subtract 3. And a half of 4 is 2. 2 minus 3 is -1. So write 4, down 1. And notice that they're all lining up, which is good because this thing's linear. Okay, so there you go. So draw your line, and then let's make sense of it here. So when you have the function y equals 1/2 x minus 3, let's write it over here. So y equals 1/2 x minus 3. The slope is right here. It's 1/2, and that's rise over run, which means you go up 1, right 2, okay, from the y-intercept, which is -3. So here's -3 right here. There's your y-intercept. All right, and if the slope's 1/2, then you go up 1, right 2. So up 1, right 2, up 1, right 2. And you can see this little staircase effect going on, okay, in your slope. So check the slope. All right, so we plotted by the line by using 5 points in this case. Make sure all the points line up. So all the points must line up. All right, why? Because it's linear, and that's what it means. Well, that's one of the meanings. Is a linear means it's a straight line. If they didn't line up in a straight line, then obviously it wouldn't be a linear function, okay? And notice the name linear has the line within it. Kind of makes sense, doesn't it? All right, so let's try another one. Now here the denominator is 3. So let's pick multiples of 3, just to make the arithmetic easy. Not that you have to, but if you don't, you're going to have a lot of fun doing arithmetic. Just try it. If you don't do that, just give it a shot. So -3, 0, 3, and let's say 6. All right, so here we go. So -2/3 times x plus 1. So -2/3 times, excuse me, not 6, but -3 here. All right, plus 1. And let's do the arithmetic. 3 divided, first of all, a negative times a negative is a positive. 3 divided by 3 is 1, times 2 is 2, plus 1 is 3. You always multiply these. So I divided 3 by 3 to get 1. Take 1 times 2 to get 2. Add 1 to get 3. Got to do your arithmetic. All right. And if you didn't get that, let me do it again. So you take 2/3 times 3. The easiest thing to do is divide first. So 3 divided by 3 is 1. 1 times 2 is 2. And then so this whole thing right here is 2. And then you got to add 1 to get a total of 3. All right. Be good at fractions. So -2/3 times 0 plus 1. Well, that's just 1 because anything times 0 is 0. So then you have -2/3 times 3 plus 1. Well, the 3's cancel, right? And you get -2 plus 1, which is -1. Notice the change in y is -2. Okay, it's going down by 2 each time, so I'm expecting that. So the next one should be -3 when we're down. Let's find out. So -2/3 times 6 plus 1. Well, 6 divided by 3 is 2, times 2 is -4, and -4 plus 1 is -3, which is what I expected, because the change in y is -2. Okay, now let's graph. -3, 3, so left 3, up 3. 0, 1. 3, -1. And then 6, -3, so right 6, which is about here, down 3, which is right about here. All right, take your straight edge out and draw your line. Okay, there you go. Now let's analyze this. The slope is -2/3, which means down 2, right 3. Remember, it's rise over run. The y-intercept is 1. So you start, all right, at 0, 1. That's your y-intercept. And notice that it's right here. Okay, which means that I got it at least right now. All I have to do is check the slope. I got to go down 2, right 3. So down 2, right 3. Down 2, right 3. So it's -2/3. So you use the slope to check. Okay, get smart. Use the slope to check the line, see if it's right. So after you graph your points, okay, draw a line, use your slope to verify it. Be smart about it. Okay, let's see, what else? Points up. Okay, points of form. Here we go. This is lesson 5.4. Okay, I had 2 lessons on 5.4, but this, pick either one. It's the same idea. Okay, so when on this right here, you got to find the slope first. We're going to subtract up. Okay, why? Because you got to take the second y value, subtract the first. Now the y values come second. So when you're finding the slope here, that's a 5 minus 8. All right, subtract up. On the x values, x2 minus x1, so it's 3 minus 0. That's -3 divided by 3, so the slope's -1. That's your very first step here is you first find the slope. Notice the steps here. Right here. All right, and then, all right, step 2 would be to use your point-so form. But first I got to pick a point, and I'm going to pick this one. Why? Because it's easier to pick. Why? Because there's a 0 involved, and 0 is easy to deal with. So you always pick a point if it has a 0 involved. So x1 is 0, y1 is 8. So I have y minus the 8 now. Okay, just substituted that in. Slope's negative 1. And you get times the quantity x minus the 0. So let's simplify. So you get y minus 8 is equal to negative 1 times x, which is just negative x. And the 0, well, that doesn't affect anything, so don't distribute there because you get 0. Add 8. Okay, and you get y equals negative x plus 8. And that is slope-intercept form. Okay, if I want to graph it from here, it'd be easy because there's your slope and there's your y-intercept. Slope-intercept form. All right, so we just went from 2 points to an equation, which we could graph if we wanted to. All right, and that is section 5.4, if you're paying attention here. Okay, let's do it again. Let's subtract up. So find your slope. So it's a 5 minus 1. Always start off with your y values. 5 minus 1 divided by 1 minus 3. That's 4 divided by negative 2. So that's the slope's negative 2. All right, doesn't matter which point you pick, so I'm just going to pick 1 comma 5 just for funsies here, and this is x1, this is y1. So I have y minus the 5 in this case, all right, is equal to negative 2 times x minus 1. So notice that I substituted 5 in for y1. I substituted in 1 in for x1. Okay? Now you solve for y, and you got to distribute. So you have y minus 5 is equal to negative 2x plus 2. All right, negative 2 times negative 1 is positive 2. And after you add 5, you get y is equal to negative 2x plus 7. Now remember, if this is since this is a video here, guys, you can pause, play, rewind, do all those things. It's a video. So if I go too fast, rewind it and listen to it again. All right. Now, next skill. Transform to standard form. This is section 5-5. Okay. Section 5.5. Okay, now standard form right here is a times x plus b times y equals c. You got to get your variables on one side. Get your variables, all right, on the left. All right, and again, no fractions. Remember that? No fractiones. All right, so the very first thing we got to do is clear the fractions. So let me write that down. So clear fractions. All right, that means we multiply by the denominator. All right, multiply by whatever the denominator is. In this case, it's 11. All right, so multiply this side by, oops, not 7, but 11. 11 here, multiply the left side by 11. All right. All right, so let's do that. Okay, so the left side's easy. You got 11y equals. Now distribute. Now here, let's do some side works. So 4/11 x times 11. All right, notice how the 11s cancel, and it gives you 4x. Notice no fractions. So I get 4x here minus 11 times 2, or 22. Almost done. Subtract 4x and get the variables on the other side, and you're done. All right, negative 4x, 11 right here. I added the opposite to both sides, so I add the 11y because it's positive, and that equals negative 22. And that, my friends, is standard form because all the variables are on the left, and there are no fractiones. Okay? Like I said over right here, no fractions. The integers a, b, and c, the a, b, and c values had to be integers. Okay? A, b, and c cannot be fractions. All right, and the last thing we need to do is graph, okay? And this is These lines right here, these horizontal vertical lines, are section 5.5 as well when I talked about how to graph horizontal and vertical lines. All right, so on the first one here, x equals -3. Let's find 2 points that satisfy this equation. So -3, comma, whatever you want. Y can be anything. So I'm going to make up a value here. And then I'm going to make another value up. So -3, comma, -3 maybe. So you plot. Okay, so let's do that. So -3, 1 would be left 3 down 1. Excuse me, left 3 up 1. And then that's left 3 and then up 1. And this is left 3 down 3. So left 3 down 3 is down here. So this line is vertical. Draw it long, use your straight edge, and then label it. Okay, it says label each line. All right, label. Keyword label. So this is A. Okay, and I'm not going to label it A. Well, I can label A. I'm going to label it the actual equation, x equals -3. It's a vertical line through -3. It's that simple. Here's -3 on the number line. The next one, y equals 4. Well, that's different, right? Y equals 4. We need 2 values, or 2 ordered pairs, that is. So how about 1 comma 4 and 3 comma 4? Notice the y value is always 4. So 1 comma 4 would be right 1 up 4. 3 comma 4 would be right 3 up 4, and it'd be right here. And then there we go. Y equals 4, and that's equation B. Okay, here's equation A. So label your lines. When you put more than one line on a number line here, guys, you better label, all right? Otherwise it gets too confusing. Okay, y equals x minus 2. So y equals x minus 2. Okay, the slope is 1. All right, which is the same thing as 1 over 1. And this right here, b is -2. So I start at -2, and then I go up 1, right 1. So up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. All right, use the slope. Now take your straight edge out, draw that puppy. All right, and then label it. All right, this is C. So, all right, and then let me see, x equals 5. X equals 5. So you need 2 points where x is 5. Piece of cake. How about 5 comma 0? How about 5 comma 2? Excuse me, -2. Just pick any 2 order pairs where the x coordinate's 5 and plot them. So let's do it. And this one is D. Okay. So 5 comma 0 is right 5. 5 comma -2 is 5 right down 2. And then draw your line. Okay. And that is D, or x equals 5. It's a vertical line through 5. Just like this vertical line over here, it was a vertical line through -3. X equals -3 is a vertical line through -3. Same idea, different number. Okay, now this one here, the slope is 1/3, the y-intercept's -2. So, oh, I already got a point there, but the slope is 1/3. So go up 1, all right, right 3 this time, plot a point. Up 1, right 3, plot a point. So you take your straight edge out after you plot a few points, draw your line. There you go, right there. So I just used the slope twice. Up 1, right 3, up 1, right 3, up 1, right 3. Okay, you can see your slope right here. Up 1, right 3, up 1, right 3. And that, my friends, is E. There's E. And then F, this right here, the slope is -1. And the y-intercept is 1. So you start here at 1. And the slope of -1, well, that's -1 over 1. So that means down 1, right 1. So from here, you got to go down 1, right 1, down 1, right 1, down 1, right 1. It has negative slope. So you plot a bunch of points. Okay, if you want to reverse it, then write it like this. Okay, go up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. And then you plot it that way too. You can reverse the slope. And if you didn't know that, well, you just learned something. Okay, so let's draw this line here. Okay, so this one, the last one here is F. This one's F right here. You can label it down here, wherever you want to label it. Just label all your lines, okay? That's important because whenever you have more than one online graph, you must label. Okay, that's it. Okay, and remember, this is a video, right? So, and this is Mr. Ainsworth here. This is Unit 2 review. Get ready for your test coming up and go through it, do your best, and I'll see you in my next lesson. All right, I'm out of here. Bye-bye.